You are kneeling beside a prehistoric river, looking for something useful, a sharp stone, a freshwater shell, maybe lunch, if lunch is feeling cooperative. Then, sunlight catches a yellow speck in the gravel. You pick it up. It does not cut hide, crack bone, hold water, or help when a predator decides you look edible. By every Stone Age standard, this object is spectacularly unemployed. The obvious story is that humans discovered gold only after they invented mines and furnaces. But that story is too neat. Gold can occur in nature already metallic, released from rock and concentrated by moving water in stream gravel. Someone could encounter it without understanding ore, chemistry, or even metal. But noticing a shiny pebble is not the same as discovering what gold can do. Why keep it? Why carry it home? And how did humans learn that this strange yellow material would bend instead of shatter, keep its color, and eventually become something worth placing on bodies, inside graves, and in the hands of powerful people? The answer leads from river mud to a tiny prehistoric bead, chemical traces inside ancient metal, and a cemetery where gold became a social language. So, how did a stone collector meet the material that would reorganize wealth, status, and human anxiety? Let's go back to the river. The short answer is that ancient humans probably found gold in river gravel, already exposed as metal. No mine shaft, no furnace. No dramatic inventor announcing that civilization had officially entered its expensive phase. The honest answer is less satisfying. We do not know who found it first, where that happened, or how long people had been collecting it before the oldest objects we can date. Prehistory rarely preserves the beginning of an idea. It preserves the things people dropped, buried, burned, or forgot to recycle. What we can say is that gold has an unusual advantage over most metals. It can occur naturally in native metallic form, without being locked inside a chemical compound that must first be smelted apart. A person could therefore hold recognizable metal before anyone understood metallurgy in the later, technical sense. And by the middle of the 5th millennium BCE, communities in southeastern Europe were already doing much more than admiring yellow specks. They were deliberately shaping gold into small ornaments. A few centuries, or perhaps many millennia, of missing experimentation may lie between those surviving objects and the first curious hand beside a stream. That gap matters. Archaeology can show us when gold working becomes visible. It cannot show us the first time someone noticed gold, carried it home, or discovered that hitting it produced a dent instead of a pile of fragments. So the first discoverer was probably not a miner or a king. It may have been an ordinary stone collector who picked up the wrong pebble and decided not to throw it back. Now we need to explain why the gold was sitting there in the first place. Gold begins inside rock, often in veins formed by geological processes far below the surface. Then weather gets involved. Rain enters cracks. Rivers cut valleys. Heat, cold, and time break the surrounding rock into smaller pieces. The rock moves. The gold comes loose. But gold does not travel like ordinary sand. Pure gold is extraordinarily dense, about 19 times denser than water, and far heavier than most common rock. A strong current can push small particles downstream, but when the water slows, the heavier material drops first. Gold settles into cracks in the riverbed, behind large stones, near bedrock, and inside layers of heavy gravel. Over long periods, a stream can carry away lighter material while leaving gold concentrated in particular places. This is called a placer deposit. It is essentially geology performing several jobs before a human arrives. Breaking the rock, transporting the pieces, sorting them by weight, and placing the interesting material where someone digging in the gravel might see it. An unpaid mineral processing plant. Very efficient, terrible customer service. Ancient people did not need to understand any of this. They only needed reasons to work near water. Rivers provided drinking water, fish, clay, reeds, shells, and stones suitable for tools. A person searching the shallows or turning over gravel could encounter a bright particle that had already been separated from its original rock. So nature may have completed the first half of gold metallurgy by accident, but rivers also carry mica, pyrite, quartz, and other things that flash in sunlight. A glint could attract the eye. It could not explain why one yellow object was carried home while thousands of other shiny stones were abandoned. For that, Somebody had to touch it. A shiny rock story is tempting because it feels complete. Humans saw something bright, liked it, and gold became valuable. That probably explains the first glance. It does not explain the second. Rivers contain plenty of minerals that catch sunlight. Pyrite can look yellow and metallic. Weathered mica can flash like tiny mirrors. Chalcopyrite can imitate gold well enough to confuse people even now, despite the fact that we have laboratories, reference books, and online arguments. The difference appears when the hand gets involved. Poke many gold-like minerals and they flake, powder, or crumble. Scratch or strike native gold and it tends to gouge, dent, or flatten. Gold is soft and malleable. Instead of behaving like a brittle stone, it accepts a new shape. That is a small physical detail with enormous consequences. Imagine someone placing the yellow piece on a flat rock, then striking it with another stone. The first blow does not destroy it. The second spreads it wider. A sharp tool leaves a groove. Pressure turns a lump into a thin edge or flattened sheet. This was not necessarily a planned experiment. Humans test materials constantly by cutting, scraping, biting, drilling, heating, bending, and hitting them. The earliest materials laboratory required one curious person, 2 stones, and absolutely no safety regulations. So, the conventional story breaks in half. Shine may have caused the discovery, but malleability created the relationship. Gold was not merely beautiful. It was strange in a repeatable way. It responded to human action and preserved the result. And once people learned that, the object was no longer just a pebble. It was a material. The next clue is almost absurdly small. A prehistoric gold bead that may preserve one of the earliest surviving steps in that transformation. Now here is the part nobody expected. One of the best clues to the beginning of goldworking is not a crown, a mask, or a treasure chest. It is a bead just 3.4 millimeters across. It came from Tell Yunatsite, a prehistoric settlement mound in southern Bulgaria. Archaeologists did not spot it gleaming dramatically in a royal tomb. In 2016, it emerged from a flotation sample taken from a charcoal-rich layer lying directly on the floor of an ancient building. Humanity's early relationship with gold was recovered from what was essentially a bucket of wet archaeological dirt. The bead weighs just 0.15 grams. But making it required several deliberate steps. Its maker began with a narrow band of gold, cast it, wrapped it around a thin cylindrical object, and polished the outer surface. The two ends overlap slightly rather than meeting perfectly. That tiny imperfection is useful. It lets us see the sequence of actions left by a real pair of prehistoric hands. Based on its secure stratigraphic position, associated pottery, and the site's complicated radiocarbon sequence, researchers placed the bead in the Middle Chalcolithic around the middle of the 5th millennium BCE. That would make it older than the famous late Chalcolithic gold from the Varna I cemetery and place it among the earliest known worked gold objects anywhere in the world. But the bead offers another clue. Researchers analyzed its composition and compared it with placer gold collected from the nearby Topolnitsa and Luda-Yana rivers. The bead contained more than 93% gold. The river samples and artifacts varied, but their major and trace element patterns were close enough for the researchers to argue that a local relationship was probable. In other words, the gold may have come from the river system beside the settlement. That is powerful evidence. It is not a geological return address. Different deposits can overlap chemically, and only 2 artifacts were tested. The bead does not prove that Yunatsite was where humans first discovered gold. It shows something more defensible. By the middle of the 5th millennium BCE, people there knew how to obtain high-purity gold, cast it, wrap it, polish it, and turn it into an object small enough to lose in one careless afternoon. The river hypothesis now has an archaeological address. But one bead is still personal. The next discovery shows what happened when goldworking became a developed craft. By the time gold reached the cemetery at Varna, the experiment beside the river had become something far more organized. Varna lies near the Black Sea coast of present-day Bulgaria and dates roughly to 4,554,450 BCE. Its graves contained thousands of gold objects: beads, rings, pendants, domed appliques, armlets, and thin sheets wrapped around tools or ornaments. This was not one clever person repeatedly flattening the same nugget. It was a developed vocabulary of shapes, The manufacturing traces reveal why that matters. Some objects were hammered and formed from sheet, others were cast. The Varna metalworkers could even use lost wax casting, in which a model is shaped in wax, enclosed in a mold, melted away, and replaced with liquid metal. They also produced some of the earliest known intentionally mixed gold and copper alloys. That requires more than noticing that gold bends. You need controlled heat. You need molds. You need to understand how molten metal moves, how much material a shape requires, and when an object has cooled enough to handle without turning your workshop into a very brief religious experience. The forms also multiplied. Earlier gold finds from nearby Varna II and Durankulac are dominated by simple, ring-shaped or tubular beads. At Varna I, gold appears as beads, pendants, body ornaments, complex armlets, decorative sheets, and objects made for particular burials. The material had moved from curiosity to design. But there is an important caution. Varna was extraordinary, and its craftsmanship cannot automatically represent every Copper Age community. Nor does it prove that goldworking began there. In fact, the skill is so advanced that researchers argue the craft had probably already moved beyond its earliest inventive phase. Varna does not show us gold being discovered. It shows us what happened after generations of people had learned to control it. The useless pebble had acquired casting techniques, customized forms, and people who knew exactly what they were doing. Yet it still made a terrible axe. So, what was all this work actually for? Gold had now become a technology, but it still had a serious employment problem. Copper could become a blade, an awl, or an axe. Stone could cut, scrape, grind, and smash. Gold was too soft for most of that. A gold knife would look impressive right up until the moment you asked it to behave like a knife. So, why spend time collecting and shaping it? First, gold was visually difficult to ignore. Its yellow metallic surface stood apart from bone, shell, stone, and copper, especially when worn against skin, hair, or dark fabric. A small amount could produce a large visual effect. Second, it endured. Gold resists corrosion and ordinary weathering. Wood rots, fiber breaks, copper changes color. Gold can emerge from soil or a grave still looking disturbingly pleased with itself. And third, it was unusually cooperative. It could be hammered into thin sheets, drawn into narrow forms, wrapped, folded, pierced, and polished. A rare nugget did not have to remain a nugget. Skilled hands could spread its visibility across a much larger object. None of this proves that prehistoric people thought gold was beautiful in exactly the way we do. They may have valued its shine, permanence, rarity, its resemblance to sunlight, or simply the labor and access required to obtain it. Different communities may have understood it differently, but the earliest surviving pattern is clear enough. Gold appears primarily as ornament, not as equipment. It marked bodies, clothing, and burial objects. It did not make a spear more lethal. It made a person more noticeable. And that may be the crucial point. Gold's weakness as a tool freed it to do another kind of work. It became a signal. Once a material can tell everyone who is special, connected, protected, or important, the next question is unavoidable. Who gets to wear it? Gold did not remain a Balkan story. But it also did not move across the ancient world in one neat, traceable line. Far to the southeast, a group of gold and electrum rings was deposited in the Chalcolithic burial cave at Nahal Kana in the southern Levant. The region is better known for its early copper metallurgy, yet these rings show that gold had also entered a world of carefully selected materials, burial practices, and objects that were not distributed casually. Later, in Egypt, the earliest surviving gold artifacts from the 4th millennium BCE are mostly modest beads and ornaments rather than crowns, statues, or coins. The pharaoh-sized quantities came much later. Gold began small. That pattern appears repeatedly. Early gold is attached to people, clothing, and the dead long before anyone stamps a ruler's face onto it or publishes the daily exchange rate. But we should resist drawing arrows too confidently across the map. These finds do not prove that Balkan goldworkers taught Egypt or the southern Levant, nor do they prove that every region independently discovered the entire process. Objects, skills, raw materials, and ideas may all have traveled in different ways, and the surviving record is badly incomplete. Across separate communities, humans kept assigning gold similar jobs. It made bodies visible and accompanied selected people into burial. Gold was not money yet. It was closer to a wearable announcement. And announcements only work when everyone understands the message. The moment gold became wearable, it also became readable. At Varna, gold was not spread evenly through the cemetery like a participation prize. Some graves contained little or none. A small number held extraordinary concentrations of gold, copper, fine stone objects, and other labor-intensive goods. There were also symbolic graves containing rich offerings without a complete human body. That pattern tells us that the objects were doing more than decorating the dead. They were helping the living describe them. A gold ornament could announce access to rare material, skilled hands, exchange networks, and surplus labor. It could mark age, identity, ritual authority, family connection, or a social position we no longer have a word for. We should be careful here. A rich burial does not provide a prehistoric job title. It does not automatically identify a king, priest, warrior, or chief. Funeral displays can express grief, community ideals, ancestral claims, or the ambitions of the people arranging the burial, not simply the power of the person inside it. But the unequal distribution is still difficult to ignore. Gold had become a way to make difference visible. This was its third discovery. First, the eye noticed a yellow material. Then the hand learned that it could be shaped. Now, the group learned that it could shape how a person was seen. A mammoth tusk can also display status, but it is inconvenient to wear. Gold compressed rarity, labor, and attention into a bead or shining sheet small enough to travel on the body. And once status can travel, it can follow someone into a meeting, a feast, or a grave. Gold had become social language. The problem with social language is that it does not merely tell people who belongs. It can also tell them who does not. Gold did not invent hierarchy. Humans were already perfectly capable of deciding that some people mattered more than others without help from a shiny metal. But gold gave those differences a powerful new costume. It was rare enough that not everyone could obtain it. Finding and shaping it required access to particular places, technical knowledge, and other people's labor. Once made, it remained bright and portable. A distinction once carried by memory or ceremony could now be worn on the body and placed beside the dead. At Varna, that visibility was uneven. Some burials contained no grave goods at all, while a few held extraordinary concentrations of gold and other carefully made objects. The contrast is real. Its meaning is less simple. Recent research warns us not to translate rich graves directly into permanent economic classes. Grave goods do not align neatly with diet, and the cemetery may express several overlapping kinds of identity: individual, family, communal, ritual, or regional. A funeral is not a prehistoric tax return. It tells us what people chose to display at death, not every detail of how the deceased lived. Still, display matters. Once gold became a recognized signal, controlling it meant controlling attention. Those who possessed it could appear connected, protected, sacred, successful, or simply different. Those without it became part of the contrast, whether anyone intended that or not. Gold did not create human inequality. It arrived extremely well dressed and made inequality easier to see. And because it resisted decay, those differences could keep shining long after the people who arranged them were gone. So, what is the real answer? We know that gold can occur naturally as visible metal. Weathering releases it from rock, rivers transport it, and its unusual density concentrates it in particular layers of gravel. That gave ancient humans a way to encounter gold without mines, furnaces, or any understanding of chemistry. We also know that by the middle of the 5th millennium BCE, people in southeastern Europe were deliberately collecting and shaping it. The bead from Tell Yunatsite preserves an early sequence of casting, wrapping, and polishing. Varna shows what followed: sheets, beads, cast forms, alloys, and a sophisticated craft already far beyond its first experiments. The strongest inference is that the discovery began near water. Someone noticed native gold, picked it up, and learned through handling or striking it that it dented and flattened instead of breaking like stone. That reconstruction fits the geology and the physical properties. It is still a reconstruction. We cannot identify the first person, the first river, or even the first region. Gold may have been collected for generations or much longer before anyone made an object durable enough to enter the archaeological record. We also cannot know exactly what the earliest collectors believed the material meant. But the discovery itself happened in stages. Nature exposed gold. The human eye noticed it. The human hand discovered that it could be shaped. And human society decided that its shine, rarity, and permanence could stand for something larger than the metal itself. Nature revealed gold. Human hands discovered its properties. Human society invented its value. You are still responding to that pebble. Gold now appears in wedding rings, medals, investment vaults, and microscopic electrical contacts. It remains rare enough to feel special, stable enough to outlast its owner, and workable enough to become almost any shape we demand. A prehistoric craftsperson could hammer it into a bead. A modern engineer can spread it across components so small that nobody wearing a gold necklace would notice them. But the strangest continuity is social. Gold still tells stories before anyone speaks. It can signal commitment, achievement, wealth, authority, tradition, or the fact that someone had a very ambitious budget. We have built markets, currencies, mines, laboratories, and entire industries around a reaction that may have begun when sunlight struck something unusual in river gravel. Return to that first collector. They are holding an object that cannot cut hide, keep them warm, or provide dinner. They do not know about kings, wedding rings, central banks, Olympic medals, or the anxious little number beside the word gold on a financial screen. They only know that this material does not behave like stone. It shines. It bends. It remembers the shape of the hand that struck it. That yellow speck was still spectacularly unemployed. We were the ones who eventually gave it one of the most powerful jobs on Earth.